sine of 2 theta is 2 times sine of theta cosine of theta, okay? So I just need to divide this over. Integral from 0 to pi over 2. Integral from 0 to 2 pi. Integral from 0 to 1, okay? I'll write this on the side if you guys can see this. Just to recall that sine of 2 theta equals 2 times cosine of theta sine of theta. Okay, so I can use this identity to make my life just a little bit easier. I need to divide by 2, so I have an 8 rho cubed sine of 2 phi. D rho, d theta, d phi. That's a phi. Okay, I'm done simplifying, I promise. Let's continue on to our integration. 0 to pi over 2, still have 0 to 2 pi. What am I integrating with respect to? Rho, so this bit stays the same, okay? What do I have? I have rho to the 4th divided by 4, so 8 divided by 4 would give me 2. This is going from 0 to 1, and I leave the rest alone. Sine of 2 phi, and I just did d rho, so I have d theta, d phi left. Okay? I guess I haven't used this, but I need to erase it. Let's continue this. Equals. Have I plugged in yet? No. Integral from 0 to pi over 2. Integral from 0 to 2 pi. Plugging this in, that 0 is not going to do anything to my rho, and the 1 to the 4th is just going to give me 2, whatever that's tacked on. So I have 2 sine 2 phi d theta d phi. Okay? That is correct, right? Let's see. Yes. Oh, I already have my pages. 2, beautiful. Okay, now notice that this bit, I'm going to be integrating with respect to theta. This has nothing to do with theta, okay? So whenever I integrate it, I'm just going to have a theta tacked on to sine 2 phi theta. Theta is going to go from 0 to 2 pi, okay? The 0 is not going to do anything. The 2 pi is just going to go in here and make this 4 pi, okay? So, what does this give me? Equals integral from 0 to pi over 2. 4 pi, like I said, and that sine of 2 theta, 2 phi rather, gets left alone. D phi. Okay? Final integration. This is going to give me negative 2 pi cosine of 2 phi. Sometimes I just write them and then differentiate back to make sure that I don't need to make any tweaks. Derivative of cosine will give me a negative sign, so I have a negative to counteract that. Whenever I take the derivative of the inside, I'm going to be multiplying by 2, so I divide it by 2 to counteract that, okay? So this will give me negative sign, so good. Multiplying by 2 will give me 4 pi, good. All right. This is from 0 to pi over 2, okay? Let me pull this out, and let's be careful. This looks like cosine, I'll write it, of pi minus cosine of 0. What does this give me? Negative 2 pi. Cosine of pi gives me negative 1. Minus cosine of 0 gives me positive 1, so this is negative 2. So this gives me 4 pi. Beautiful. Okay. Let's do some more examples. Because they can get harder than this one. That's for sure. But yeah, the key to not being thrown off or being surprised whenever you're doing these kinds of problems is to do so many of them that you have seen pretty much every type of problem that these books will give you, or what anybody can have to offer, okay? So yeah, like I said, the key is not just looking at the first lesson or the first bit of the lesson and saying, oh, I can reparameterize everything, I should be good, okay? You'll get stuck if you just think that. So we need to do a lot more examples. How about this one? Example. Triple integral for E. And my integrand is going to be zx dv. Okay, so now what is E? where E is above. Like I said, I always like to underline those. So while it looks like I'm above a sphere, x squared plus y squared plus z squared equals 4. It's a sphere centered at the origin, radius 2. I am inside the cone. And this cone is tip pointing up. So it's kind of like an upside down ice cream cone. Tip pointing up. That makes, what's our information about this cone? That makes an angle of pi over 3 with the negative z-axis. One more thing, and has x being strictly positive. Sorry, not strictly positive, greater than or equal to 0. Okay? Now, at first it might be tempting to say, oh, an angle of pi over 3 with the z-axis, and say that, oh, immediately phi goes between 0 and pi over 3. But this is the negative z-axis, okay? What phi is usually measured from is from the positive z-axis, okay? So let's not make that assumption quite yet, okay? But first let's talk about something a little bit simpler, because it looks like rho is kind of right over there looking at me. So we're inside of a portion of our sphere of radius 2, okay? So from that, I can just immediately say that rho goes from 0 to 2, okay? Because the radius of this sphere is 2, okay? You can look at x squared plus y squared plus z squared equals 4. Thus rho squared equals 4. Thus rho equals 2, positive only because it's strictly positive. Well, 0 or 0 or greater, okay? So I have rho. Now, let's go back to talking about phi, okay? Like I said, it makes an angle of pi over 3 with the negative z-axis, okay? But we're usually measuring from the positive z-axis, not usually, always, okay? So I'm terrible at these pictures, but let's kind of try. I'm looking at kind of an upside down cone, okay? This is going to be my negative z-axis, this dotted line. And it says from the cone, this is hard to draw, to here, this bit is pi over 3. And we know the whole thing extends from, or our range can extend from 0 to pi, okay? So it kind of looks like we need to start here and measure on down this way, okay? And what would this be? This would be 2 pi over 3, right? 2 pi. Because one more pi over 3 on that would get me to pi. So it looks like this is 2 pi over 3. Where we need to start and end all the way down here, okay? So it looks like that's our range for phi. What else do we need? We need theta. And like I said, for theta, most often, I can look down at an XY plane projection and get information about theta from that, okay? I know that from, and I've used pretty much all of my information. I use that to get rho. I use this to get phi. Looks like all I have left is this, that x is strictly positive, okay? Like I said, I like to just look at the XY plane for that. X is strictly, this should be negative, according to, I think I mistyped that. X is strictly positive, right? Yes, x is strictly negative, my bad. Strictly negative, okay? So if x is strictly negative, including, I keep on saying strictly, it is including 0. So if it is negative including 0, then it looks like our theta goes from here, which is pi over 2, all the way down over here, to which is 3 pi over 2. Okay, now we finally have all of our information to set up an integral. Let's erase this, and I'll move on over there. What do I have? I always like to write triple integral over e. What was my integral? Can't forget that. Cx dv. What does this now equal? Like I said, I like to just set these guys up first. Okay? Never forget rho squared sine phi. I write it first so I don't forget it. Now my integrand, zx. What is z? Z is rho cosine phi. X is r cosine of theta. Okay, so but r is rho sine of phi. Cosine of theta. Okay? And what do I have here? D rho. D theta, phi is always last. D phi. Okay, now I'll set up my bounds. Phi goes on the outer skirts. Okay, so that is going to be 2 pi over 3 up to pi. Next comes theta. That's pi over 2 up to 3 pi over 2. 3 pi over 2. Finally, rho, 0 to 2. 0 up to 2. Let's simplify this integral because it looks crazy right now. Integral from 2 pi over 3 up to pi. Integral from pi over 2 to 3 pi over 2. Integral from 0 to 2. Okay, how many rows do I have? Squared, cubed, rho to the 4th. What else do I have? I have 2 sine phi's. Cosine phi, so cosine phi sine squared of phi. I've taken care of this. I've taken care of this. I have a cosine of theta left. D rho, d theta, d phi. Make sure I didn't make a mistake there. Rho to the 4th, cosine, sine squared, cosine. Perfect. So this equals integral from 2 pi over 3 up to pi. Integral from pi over 2 to 3 pi over 2. Okay, what am I integrating with respect to first? Just rho, right? So thank goodness I get to leave all this alone and just integrate with respect to rho. This is going to give me 1/5, rho to the 5th. This is going to be from 0 to 2. And I get to leave everything else alone. Sine squared phi, cosine of theta. I just took care of d rho, so all I have left is d theta, d phi. Perfect. Let's plug this guy in. Thank goodness 0 doesn't have anything to do with it, so that makes my life easier. This is going to be integral from 2 pi over 3 to pi. Integral from pi over 2 to 3 pi over 2. 2 to the 4th. Is that 32? Yes, it is. 32 over 5. 0 makes no contribution. Cosine of phi. Sine squared of phi. Cosine of theta. D theta, d phi. Once again, it looks like things are turning out okay because these are all phi's. This is theta. This is the only thing that has to do with theta. So my integration is easy once again. I have integral from 2 pi over 3 up to pi. Integral, let's integrate. I have a 32 over 5. Leave all this alone. Cosine of phi, sine squared of phi. What does this give me? Sine of theta. And I still always differentiate this back to make sure that I didn't mess up the negative sign. Derivative is positive cosine. Good. What is this going from pi over 2 to 3 pi over 2? What's left? D phi. Okay, we are almost there. Let me erase this bit. All right. We are there. Perfect. This equals, what is my integral going from? 2 pi over 3 up to pi. What do I have here? Let's write it. 32 over 5. I have a cosine of phi. I have a sine squared of phi. Okay, what do I get here? Sine of 3 pi over 2 minus sine of pi over 2 pi over 2. This is all d phi still. Equals integral from 2 pi over 3 over to pi. What does this give me? 32 over 5. Sorry, I know some of you guys can just skip all these steps in your head, but I like to make sure that I make no mistakes. Okay, so I go through every single bit. Cosine of phi, sine squared of phi. Sine of 3 pi over 2. This is 3 pi over 2, right? So that's a negative 1. Minus sine of pi over 2, that's up here, so that's a positive 1. So this just gives me negative 2. So this equals 2 pi over 3 up to pi. Multiplying this by negative 2 gives me negative 64 over 5 cosine of phi, sine squared of phi, d phi. Missing my d phi up here. D phi. Where is where? Almost there. For this integral, I see a u sub that I can use. I can say that let u equal sine of theta. So that du is taking the derivative of cosine of theta. These are phi's, sorry. D phi. And that's exactly what I have here, okay? Let's do our bounds just to skip a step. U of pi, sine of pi is 0. U of 2 pi over 3. That gives me root 3 over 2 positive, right? Because we're in the second quadrant. Awesome. So let's continue this integral. Equals integral from root 3 over 2 to 0. Okay? Yes. Let's put out negative 64 over 5 in front. And what do I have? I have u squared, right? U squared du is all I'm left with. Cosine and d phi get absorbed by du, and I'm just left with that u squared. What does this equal? Negative 64 over 5. 1/3 u cubed 3 over 2 to 0 equals negative 64 over 5. My 0 has no contribution, so I have 0 minus